Let's prove some rules of the logarithm by using the definition. Logarithm is the inverse function of the exponential. So, if we take the logarithm of base a of 1, we should think that what power should we give to a to get 1? Any number to power 0 is 1, so this number is 0. What's logarithm of base a of a? What power should we give to a to get a? The answer is 1. If we have the logarithm of a to power x, we should find a power for a so that the result would be a to power x. The answer is x. So the logarithms cancel out with the exponential in this way. We can also think about that. Is it true that a to power logarithm of a of x would give x? Taking the logarithms of base a from both sides, we get something like this. Because of this rule, we can here cancel out the logarithm and the a, and we see that the result is true. So we see that logarithm and the exponential, they are inverse functions, so we can cancel them out in this way. Now that we know this, we can give another proof of these facts. Log a of 1 is the log a of a to power 0, which gives 0. Log a of a is the log a of a to power 1, which gives 1. How to prove this formula? Well, we can take a to the power on the right hand side, and by using the rule of the exponential function, we will get something like this. And we get x times y. Well, we can write x times y as a to power logarithm of base a of x times y. And from here we can pick up that the powers of a need to be the same. So we see that our formula is true. How can we prove this formula? We can study if the formula above would be true. We can substitute there that x is y times z. In the left we have something like this. write something like this. The y's will cancel out, and we can shift this term to the left hand side to get that. The sum of logarithms gives the logarithm of the product. We know that this is true, so our original formula is also true. How can we prove this formula? If we would take a to the power of the right hand side, we can remember the rule that a to power some product is the same thing as we take the powers separately in any order what we like. So we can express the thing as a to power log a of x to power b. In the parentheses we just get x. Well, we can express x to power b as a to power log a of x to power b. Here the a and the logarithm would just cancel out, so everything is fine. Now the powers of a need to be the same. Because these are equal, our formula is true. How can we prove the change of base formula? We can start with the numerator of the right hand side. We can write the variable in a different way. It's a to power logarithm a of x. Here the a and the logarithm would cancel out, so everything is fine. We can now take the power and take it out from the logarithm. To get something like this. And now we can divide by this number. Here a and b are both bases of logarithms, so they are both larger than 1. So this number here, it's positive. The main thing is that it's not 0. So we get that this is true, so our formula is true. We were able to prove these formulas. Logarithms involve lots of formulas, and you need just practice to learn the formulas, and then you can calculate in a fluent way.